Hi everyone, welcome to this week's Learning Space. This is the Nicole is still recovering from Dragon Con edition. I am your co-host Nicole Gugliucci and postdoc with CosmoQuest, and I have with me Georgia Bracey, our formal education lead with CosmoQuest, and we bring you a weekly show about space and astronomy, education, and outreach topics every Wednesday. Like I said, I'm still recovering from the amazing time that was Dragon Con, and I know you all had Georgia and Ellen Riley last week talking about Investigate, and I did not get to see that episode yet, and I'm super excited to check it out, since that's all about our newest curriculum, all about asteroids. So thank you, Georgia, for covering for me while I was in Atlanta.
Sure.
We have with us today Carolyn Collins Petersen. So hello.
Hi.
And we have who's the space writer on Twitter, and we have a whole bunch of stuff to talk about, including a new app she's been working on, a book that came out recently, and we'll be talking about some other cool stuff along the way. And I want to let everyone know to thank you, first of all, if you're sharing this link and sharing it with your friends and spreading the Learning Space love. If you want to send us a comment, we are using Comment Tracker in Hangout Toolbox to check the event page. So if you're watching this on Google+, on the event page, anywhere it is shared from the event page should be picked up as well. Anybody who's been sharing it out over the last few days, that should come up as well. If you're watching on the YouTube page, we are tracking those comments. Sometimes they come in a little bit slowly, but we will get to them. Unfortunately, we don't have Twitter tracking anymore, so if you can use the YouTube or the Google+, we will see those comments. So send us any questions for Carolyn or for me and Georgia along the way. Send us your comments, and yeah, hi everybody. Why don't we go ahead and get started and talk about your new app that you've started working on and sent me some codes for. It sounds like a sky app that's got a whole lot more, some storytelling aspects to it.
Well, it's called Star Map Media, and it's actually the latest generation of a series of apps called Star Map, which was created by a gentleman named Frédéric Descamps in France. So the first Star Map was actually created 5 years ago.
Okay.
He contacted me a little over a year ago, actually, asking me if I would be interested in writing what essentially were little planetarium shows to play inside the app. And so we started working on that, and I created 32 of them. 29 of them, or 30 of them, are live now. And they're basically between 15 to 17 minutes long, and they not only do they tell you about what you're looking at in the sky, but they guide you and help you find things in the sky. So if you're holding it up and you're listening to the story about the North Star, it actually puts a little pointer up there to show you how to find the North Star. When you get there, then it goes into a little talk about what the North Star is and why it hasn't always been our North Star and what Polaris is, what kind of star it is, that sort of thing. So it's a little bit of an interactive planetarium show is the way I think of it.
Except the planetarium is the real night sky. That's so cool.
That's pretty much it. Yeah. So with the map, it's kind of hard to see on this. This is, I don't know, it's kind of hard to see, but this is how it looks on the iPhone. It actually plays on the iPhone and on iPad, and you select a story. Star Map itself is also a planetarium, mobile planetarium program. That's how it got started. So you can hold it up to the sky, and it will show you what's up in the sky at the time. And so at the time that you're looking at it. So if right now, if I had the sky turned on, it would show me while the sun's up, or something like that. But in 5 hours, it would show me whatever stars are overhead at my location. So it takes the GPS reading from your phone or your device. It uses the compass that's in there, and then it also knows where you are because you told it what city you live near when you first go into the app. So that's Star Map itself, and that is not dissimilar from a lot of other mobile planetarium programs that are out there, like Sky Safari and that sort of thing. But Star Map was actually the first one to come out in the App Store and was very popular. So Frédéric, for many years, since he released it about 4 or 5 years ago, got to thinking, what more can I do with this? So he was always adding more databases, more objects as things would come up. And then he got to thinking about, well, it still doesn't help you through the sky when you're actually out there with somebody. Say you're out there with some amateur astronomer who knows the sky. That person's going to tell you, okay, you see that star over there? That's that's the star. This is this constellation. Here's how you get to it. Here's how you star hop. So what he wanted was to have that sort of friendly, arm on the shoulder, see this thing up there kind of approach in this show. And when he came to me, I immediately said, well, this is like all the planetarium shows that I used to give, doing star talks. And then in addition to that, we're mixing in little bits of audio-visual entertainment with it. There's a narrator, there's music that comes with it, and we put in one story, we'll talk about not just the star, but also some history of it, like what the history of the constellation is, what Greek gods and goddesses people saw here, that sort of thing. So it's a little bit of a complete, what I call a star talk, what we in the planetarium community call the Green Arrow Show.
Yes.
So we still do call it the Green Arrow Show.
Nice.
So, well, I don't know, you have a planetarium. Do you have a green arrow?
We just got a planetarium. We has a red arrow.
Okay, well, the Red Arrow Show then. Yeah.
I do public observing nights and in Edwardsville, Illinois now, and we have the green laser pointer. So
yeah, well, it's the same thing.
That's aspect of both.
Yeah. So that's how StarMap Media came about. So think of it as the next generation of StarMap. Well, the media program itself is actually a standalone module that you can download for free, and you get 2 stories with it. There's a Sky Tonight, and then there's a tutorial. He also embedded that into the standard StarMap show, StarMap programs as well. So no matter which StarMap you get, if you get StarMap Media or StarMap Pro or StarMap HD, you also get StarMap Media embedded in there.
Cool, cool. So Guido Bibra asks a question that's been on my mind as an Android user. Are there any plans to port the apps to Android as well?
Yeah, I ask him that question a lot, and there are a lot of security issues with Android, and so he's thought about it. What he may actually end up doing is going to a web-based application, which is then pretty much independent of a platform.
Right.
So you could be on whatever platform. That's going to take a little bit more development. We just actually had a telecon about that this morning.
Okay. Okay. Cool. Cool. So there are different levels of the app. There's the free app. There's an HD app. There's the regular light. What are the different levels?
Okay. Yeah. So
subscription.
So let's go back to the beginning for a minute. He basically released StarMap, and that became StarMap Pro, which is what now shows on the iPhone. StarMap HD, I think, and I'm kind of guessing on this, but he mentioned once that it came about because people wanted to be able to play StarMap on their iPhones. And I mean on their iPads. You can put it on the iPad, the iPhone app, but it isn't as good. So
it's
he
like
basically
this big, on the screen.
Yeah. I mean, well, you can do the 2x on it, but it still looks like crap. So no, he came up with the HD for the iPad. Okay. And then StarMap Media is the new one that he came up with. Lite is a free version, and it's apparent. I think very soon now it's going to be that you can get Lite, and if you want to upgrade it to the full app, then you just do an in-app purchase.
Okay, very cool.
And I'm still a little bit new to in-app purchasing. I see it in games and things like that. It's complex. It's more complex. I don't program in Mac, or in Apple, so I'm not really sure what they do. I did go through a little bit of an exercise to see what it takes to make an app using the Apple platform, and they actually walk you through it pretty well.
Okay.
So now I just need a good idea for an app. At least I know what Frederick has to do. So basically, then you make all these hooks into the databases, and he's using Sinbad and whatever databases he can to populate. So it's a very, very full-featured program.
Very cool. So what kind of shows did you write for the app? Can you give us a few examples?
Yeah, let me. So on the StarMap Media page, which I think I sent you a link to, and I'm going to have to go to it myself. Hold on a second here.
Yeah, I'm at home, so my internet is a bit slower. So.
Oh, that's okay. I'm sitting on top of it. I'm sitting on the side of a 10,000-foot peak in Colorado, so.
Yes, I should warn you guys. Carolyn lives outside of Boulder with a very slow internet connection. George is the only one of us with a really stable internet.
Yeah. So the stories they're keyed to the seasons, obviously, what's going to be up in certain nights. So right now, if you turned on the app, it would offer to sell you or show you the story called Cruising the Cygnus Rift, because you can see Cygnus. And so we're talking about, when you look at the Milky Way, you're basically looking towards the plane of our galaxy and what objects you can expect to see. And Cygnus is particularly rich. You've got starburst regions, you've got black holes, you've got not too far off of Cygnus, you've got a few planetary nebulae, just sort of in that region. So that's a story that, as you're looking at Cygnus and it guides you around Cygnus, it tells you a little bit of the star legends about that region of the sky, and then also about the topics and the scientific, studies of the objects that are in it. And we talk about why it's a rift. There's another one called Stellar Smoke Rings, staying in the summertime here. It's basically talking about planetary nebulae, and we focus in on the Ring Nebula and talk about what it is. Because, that really answered a question that I always get, no matter where I go, or even when I worked at the planetarium: what's going to happen to the sun? Everybody gets this question. They think it's going to, people that don't know about astronomy think it's going to blow up because they hear about supernovae. And so then when you tell this story about what's really going to happen to the sun, it surprises them. It's a much more complex and rich story than you would think. So in some sense, coming up with these stories, we had to think about what are the questions that people ask the most about astronomy. And as a planetarium person, I could come up with a million of them that I always got at the console afterwards. Or when I go out and give lectures, because I do a lot of talks on cruise ships now too, and I get many of the same kinds of questions. Maybe they're asked in a little more civilized or sophisticated way than at the planetarium, but they still want to know what's going to happen to the sun, or what's it like inside a black hole. That's another good one.
Yes.
Yeah, we did another one called More Than Meets the Eye, which is about 3 little constellations that actually get overlooked a lot, but they have interesting things, and that's focusing on Delphinus, Sagitta, and the Eagle, Aquila.
Yeah.
And so, of course, as soon as we put these stories out, you get these great things like Nova Delphini 2013, which come up, which we couldn't talk about in the story. But I've been in the middle of, on our Facebook page for the app, I've been writing a lot of stories about, okay, in this area of the sky, when you're looking at it, there's this nova now. So when you're navigating around to look in the sky, take a look for this, and you'll learn more about it.
All of a sudden, Delphinus got a little boost in popularity from that nova. So
everybody did. Delphinus did, and it's also one of the few constellations that looks like what its name is too.
Yeah, it's so adorable.
So another one, let's see, Riding the Celestial Horse, talking about Pegasus, M15. What happens when galaxies collide? That's a good excuse to talk about Andromeda Galaxy and what's going to happen in 5 billion or so years. It kind of goes like that. There's a web page on StarMap Media page. Actually, there's a link called Stories, and you can go and look at what the stories are all about. Wandering the Summer Sky. We tried to come up with some really unique approaches to this, so that we weren't talking about the same things all the time. So we wanted to talk a little bit about some constellations that you don't always hear about. So there's a story called Asclepius. And it's about the doctor and the snake, and we're talking about Ophiuchus and serpents, and we just talk about how doctors and snakes kind of come together, but that gives us a chance to talk about Hercules and Ophiuchus and serpents and some of the stars in the area, Zeta Ophiuchi and that sort of thing, Ophiuchi, the star birth region, and it's just, when Frederick first talked to me about it, he kind of had these visions of, well, we have these little topics we'll talk about. When we got done with it, we looked at it and said, we've just written an astronomy book here. It's a multimedia astronomy book in a lot of ways, because using all of these topics, we could then teach some very fundamental, rudimentary things about astronomy, like, what's RA in DEC? How do you find north in the sky? That sort of thing. And we use it in a storytelling mode to be able to teach that.
Well, you've got the few stories are a really cool way to kind of hook people into the content, right? And then, the finding your way around the night sky, that's a great way to, do the same thing. It's a really nice hook.
It is, because it's one thing to read about it in the book, and I've read a lot of books. I've written some books, about astronomy, and sometimes you feel like you're going over the same territory over and over again, and you want to find a new way to do it, and this really allowed me to do that.
Yeah. Are there any constellations you haven't woven into a story, or?
Oh, yes, the entire southern hemisphere.
Okay,
and sorry, Aussies.
Well, no, we're going to do that, and we're getting a lot of requests for it, but also things that are very close to the celestial equator, and like Sagittarius and that sort of thing. We have not done one on Sagittarius yet. And of course, all the great news this week's been about Sag. So that's sort of in the next batch. We had to figure out what we could do in 30 stories. And also, some of it kind of reflected, where he thought most of the population of the world was for the first set, and a lot of them are between 40 and 50 degrees north latitude. As you get farther north, then you're not going to be able to see some of these things. I argue with them a lot about that. We have these discussions about it, and I think what we agreed that we know we'll be doing some for the next, basically moving our way south.
Okay.
River Eridanus would be really interesting, Yeah.
I would use the Southern Hemisphere app just here, because I don't know anything. I mean, I've been to the Southern Hemisphere, but I didn't know anything about the constellations or their stories. I would just use that sitting here at 40-something latitude.
Yeah, it's really interesting. The Southern Hemisphere constellations are reflect a lot more of the age of exploration than the Northern Hemisphere ones. The Northern Hemisphere ones, you've got people around the world that saw a bear at Ursa Major, even if they didn't know that it was Ursa Major. You get, lots of cultures saw this. You go down to the Southern Hemisphere, and maybe those people living down there had names for it. I know they did. Zimbabwe, they have traditions of like hundreds of constellations, but it was the Northern European, people who went around and named all these things. So you get the air compressor and things like that.
Microscopium.
Yeah. So it's a little odd. It's a little odd. So that'll be interesting to write those stories, because there is not this, the ancient Greeks saw an air compressor here. Well, no, they didn't.
Right.
Somebody saw an air compressor here. Some guy on a ship. So that's kind of what's been keeping me busy in one of my hats is working on this. It's basically Frederick as a client, and I've been lending my writing expertise to that, and then the other thing I did was I had to go and pronounce a lot of the star names that we talk about, because I didn't narrate these, and I'm pushing for a female narrator for some more of these as well. But right now he had a guy in mind, and the guy lives in Los Angeles. Very good, very wonderful voice, but couldn't pronounce star names, save his life. So I had to read all these star names to him, and basically act as sort of the narration advisor for that.
We had to have, when I was at University of Virginia, we had a pronunciation guide for all the stars and constellations for the grad students and the volunteers, because a lot of us don't know these names, or we've read them, or there's arguments over how to pronounce it, and so we tried to make it consistent.
Yeah, every time I go to an astronomy meeting, there's, no, Betelgeuse isn't really pronounced that way, it's Betelgeuse, or I heard somebody call it Betelgeuse, and so I went back, I actually got into an argument with somebody, I went back to the original Arabic and said, here's how they said it, But yeah, even in the planetarium community we have that too. Right. When I worked at Sky and Telescope, because I worked there for several years, we had a big discussion about whether it was Fomalhaut or Fomalhaut.
Yeah.
And that was a lunchtime discussion we had.
And then they found a planet around it, and we had to decide.
Yeah, and then we had to really learn it, But I remember sitting there with Alan McRobert, and he's going, no, it's Fomalhaut, I know it is.
Fomalhaut. Charon or Charon. I actually had that in one of my DragonCon talks. I'm like, look, some people say Charon, some people say Charon. Doesn't matter, New Horizons.
Well, it was the guy's wife's name.
It was the guy's wife's name. Right, but that's not how you pronounce the god's name.
Well, that's true, yeah.
Oh man. Okay, so I want to transition a little bit to some of your other writing. You have a book that recently came out about astronomy.
Can you see that? Yeah.
Oh, wait, hang on. Let me show that up. So this is Astronomy 101. This is. Can you tell us a little bit about the purpose behind this book?
Yeah. So last year I was lecturing on a cruise ship. I do this a lot. It's a really hard job. It's a really hard job. And I got an email from somebody as soon as we'd left the last possible best Wi-Fi in Hawaii, saying, "Would you like to write this book? We went 65 topics, and they had to touch on astronomy, so that everybody that reads it will get it'll be like one chapter is 1,000 words, and they get 1,000 words on the topics. You decide all the topics, except we have some we want you to cover, like black holes, warp drive." UFOs, aliens, and at the first I'm going, I don't want to do this. And then I read more and more of the proposal, and they really had a pretty solid idea. So I wrote back to them and said, sure, I can do this. I'm thinking, oh, good, I'll have 6 months to write this. Well, no, they had 8 weeks I had to write this.
Oh, my gosh.
Which is why you got a phone call, which is why you got the email.
I feel bad because I didn't get back to you until the very last minute.
It's okay. I had about 20 people or so. If you read the list of people, I had about 20 people in various states of holiday disrepair and all this. One person who ended up with pneumonia in the middle of it, which I felt really bad about. But so I had to pick. It ended up being, I think, 55 topics, and I had to kind of teach astronomy through it. It wasn't going to be a textbook. And in fact, their first idea was, we don't want it to be a textbook, and we're going to slag textbooks in our copy. In our advertising copy, and I had to go back to them and say, don't do that, because some of my best friends are textbook writers, and I might have to call them. But they said, well, we just want this to be that for someone who's like a doctor or a lawyer or a bus driver or whatever, who doesn't have time to take an astronomy class but wants to know more about it, what can they learn? And so we picked these. I suggested about 60 topics. We winnowed it down to about 55. They wanted me to write about astronomers that I knew about. Not necessarily all the same ones like Hipparchus and all that, but so I threw a few people in sort of towards the end. I have people like Vera Rubin in there that I wanted to get a good mix of astronomers and modern ones as well. And so you basically, let's see, I have to remember these. It's been a while. You know, after you write a book, it's like childbirth. I think you forget it, how painful it was. So it starts out, I started out with astronomy lingo, because I think we as astronomers speak a language that sometimes sounds a little bit intimidating to people, and we're talking about right ascension and declination and, you know, this, that, and the other. And so I just did a little bit of astronomy lingo where I defined light year and that sort of thing. And then I went right in, starting with the solar system, worked my way out to the edge of the universe. And so some of the more far out topics are, well, let's see, they wanted me to talk about certain missions. So I talked about Kepler. And I think even at that time I knew they were having trouble, but I didn't. So I tried not to talk too much in the present tense about a lot of these things. The Big Bang was a big one. They wanted me to talk about that. They wanted me to talk about science fiction. You know, where does science fiction and astronomy work together? And then the astronomers I picked out were like Galileo, the Herschel family, because all three of them were involved. Henrietta Swan Leavitt, who, if you look at my webpage, I have a little planetarium in there called the Henrietta Leavitt Flat Screen Planetarium. Albert Einstein, they said I had to talk about him, so I did. Jocelyn Bell Burnell.
Yay!
Sarah Cooper Rubin, Clyde Tombaugh, Mike Brown, people like that.
So right up to the modern day, yeah.
Yeah, and Mike was actually pretty good. He wrote back to me. I had reviewed his book about killing Pluto, and so he got back to me. And Vera Cooper Rubin, I wrote to. I found a lot of material on her, but she never wrote back to me to verify that what I wrote was correct. So I had a couple of other people read it who knew her and said, yeah, this looks pretty good.
Good.
Yeah, so gravitational lensing, just things that kind of make the newspaper is really what they wanted me to talk about. And so then I set to work on writing the book the first week of December, and I think you got it, after Christmas maybe?
Yeah, I remember working, I was on a plane working on these.
Yeah, oh right, so was I. And then AAS, I was actually working on part of it, and then right after AAS I sent it.
Yeah.
So.
I was either on a plane home or a plane to AAS when I saw it. You really had, but not only did you have the sexy topics, you had just basic how does spectroscopy work and how do telescopes work. I mean, you get all the basic topics as well. So it really makes it's a conversational tone that covers a broad range of topics in astronomy.
Yeah. No, and it worked out. It was basically me talking to a reader. Just basically having a discussion with the reader or having a conversation. And so they did not want heavy equations. I think there's a little math in there that I remembered when I was teaching. You know, I'd get these kids coming into the classroom saying, is there going to be any math in this class? And I'd say, yes, there are going to be some numbers in this math. In this class, so you're going to have to learn. So that's really where that came from. So there's not a lot.
It's very minimal.
Yeah. No, so and if you read it all the way through, then you basically get a good feeling for what's going on in astronomy. And of course, there's a lot of links to web pages and other books and other sources if people really want to follow it up.
Yeah. So
that was
really cool.
That was 6 to 8 weeks of really intense work.
That had to be intense to do all that.
Yeah.
I had chapters that I read.
Carolyn,
well, you had
a topic to talk or to write about, something from the book.
You know, it kind of goes back and forth. I really like to write about star birth, and I'm also really fascinated with planetary nebulae right now. And then the other topic that I was interested in but hadn't done a lot of reading in was, or at least not recently, was in dark matter. And they really wanted me to write about that. And of course, dark matter is just so exciting that you know you can. It's like you can blame anything on it right now because we don't understand it very well. It's like when I was working on the Hubble team. Every time something weird happened, we'd say, "Well, it's a black hole." You know, a black hole did this, and you know, and it's you see this jet, oh, it's a black hole. You know, you see this weird thing, it's a black hole. Well, and I remember when I was a kid, black holes were like this theory. It was a mathematical construct. It wasn't. I never thought they were going to happen. And now, the Hubble Space Telescope. Well, Ray Villard, if you know him, there, he said that they used to have they bring these pictures in of things that they'd taken, and they go, "Oh, there's a black hole in that." And so, and it was usually a joke, but then they brought in, I think it was NGC 4261 was the first one where they said, oh, that's a black hole, and they called it the holy you-know-what picture, because everybody walked up and looked at it and said, holy cow, look at that, it's a black hole.
Wow.
Because you could see the jets, you could see all kinds of stuff in there. So those kind of fascinate me, and those also fascinate kids, and they ask you, what's it like inside a black hole? So.
Yeah. So that's Astronomy 101. From the sun and moon to wormholes and warp drive. Key theories, discoveries, facts about the universe.
Now, isn't that the most amazing subtitle I've ever seen?
Most amazing subtitles.
They actually had the entire book designed before I started writing it. So.
Oh my gosh! Oh my god! But I like the little like circle in the front says a crash course on the science of space. So that's how you.
Yeah, I like that. I think. Yeah, no, that's actually what it is too. So, and I'm still living in fear I'm going to open it up and find a mistake somewhere. But you guys were all very helpful. 20 of you saved my butt. So. That's
amazing. That was amazing. No, yeah. So I knew about this because Carolyn sent me a few chapters to proofread, and I was a baby doctor.
Well, and that was because I read your thesis,
That's right, you did read my thesis. You helped. Yes, I owed you big time. You edited my dissertation when it was in the worst state possible.
Yeah. Well, you and Aaron, I did Aaron's the year before. So.
That's right. So I'm more than happy to help you out again because I'm sure this was so much easier than.
Somebody's thesis. Actually, your thesis is only 100 pages.
Yeah, it was a short
one. That was fairly easy.
This
was longer.
I didn't include any. All the data I just threw on an online database. I didn't even put tables or anything.
Yeah.
So yeah. Oh my gosh. So we wanted to talk. So I put the link to that in the Google Plus event page again. So I'll put that in the YouTube description after the fact as well. So go check that out. Wanted to talk to you a little bit about you've got a long history of working on planetarium shows and educational videos about astronomy. How did you get into all that in the first place?
Well, it started back when I was just got out of school the first time, and I had a degree in education, which I wasn't using. And so I went to a planetarium conference, and just to go back a little bit further, Mark and I both worked at Fisk Planetarium off and on when we were undergraduates, and that's at the University of Colorado campus. That's where we met. Well, we didn't meet there, but that's where we worked, and we got married there. And so after I graduated, we got married in '78, and we actually went to a planetarium conference on our honeymoon, which sounds a little strange. You get to go and party with your friends, on your honeymoon. So we went to a planetarium conference in Washington, D.C., and shortly thereafter, we were at some other meeting, and we saw this really awful planetarium show, and I don't remember who wrote it. It just was awful. And I said, I could write better than this. And I had been a writer before that, and I, in fact, was about to go work at the Denver Post as a science writer. I didn't know that at the time, but I about a year later started working as a reporter and a writer at the Denver Post. And so Mark said, well, you write one, and I'll publish, and we'll make it. And so I wrote my first show. It was called Light Years from Andromeda. And it was all about the concept of light speed and how we use light speed to measure certain things in the universe, distances and that sort of thing. And so we did that show. We showed it and started selling it, and sort of one thing led to another. And I think I'm trying to remember how many shows I've done now. Probably more than 30, 35 maybe. And I've also done them for other planetariums and for other companies, like Emerson Sutherland. I did a show for them. And so that was all running in parallel with me working at the Denver Post, being a writer there. They sent me out to do things like cover the Voyager mission to Saturn and the Voyager mission to Uranus. After about 5 years of that, the Denver Post had gone through a series of owners, and every time another owner would buy the place, they'd lay off another 300 people or something. So I actually made it through about 5 layoffs, and then the 5th one I lost my job. So then I decided to go back to school. And that's when I went back to the University of Colorado, and with the intent of getting an astrophysics PhD, actually. But I needed to go back and make up some classes because I hadn't studied all the science I needed. So I was back making it classes. That's when I went to work for Jack Brandt at the Laboratory for Atmospheric and Space Physics, and he hired me to work on comet studies. To look at, we had about 2,000 pictures of Comet Halley, and so we made a book about Comet Halley, and studied the large-scale structure of the tail. So we were interested in the plasma tail. At the same time, I was working my way through classes. About the time that I went to apply was about the time that they cut a lot of the graduate student funding, and there was no way I was going to get into the program. There just wasn't money for it. So he said, well, I'll pay for you to take any other major master's or PhD that you want to take, but we've got to keep you here because you're doing all this good work for us. So I went over to the engineering department and talked to them about doing telecommunications engineering, thinking that might help me out with radio astronomy. And I talked to the communications department, which was journalism and mass communications, and I put together a degree program where I could study both. And so I was the only scientist in the journalism program. And I was still doing science. I'm still over there doing research. And but over in engineering, I was like, hey, this is great. You know physics, you know astronomy, you know, this is great. So I did that and ended up with a master's degree and left the university and went to work for Sky and Telescope. Parallel to all that, I was still working on planetarium shows. Mark and I were continuing to produce them. We created a company called Loch Ness Productions, which was originally created just to sell his music. So he creates, he is a space music artist. His stage name is Geodesium, Geodesium. And we sold albums, but then we started doing shows. And so we kind of morphed ourselves into this planetarium show production company. And for the longest time, all of our shows were slides. That was slide tape was the big thing. So you ran a tape through your tape machine, and you played the soundtrack, and then all these slides would drop synchronized into all the slide projectors all around the dome. That has now changed, and most of the facilities that are modernizing have now going into full dome video. So we're now full dome video producers. And we spent several years recreating all of our old slideshows, reanimating them, revisualizing them, and putting them into full dome format. So that's what we do now. We also represent other people's shows as well.
Very cool. So we just got a couple questions over on the event page. So Guido asked, he's very excited about the book. It's really affordable. There's just the hard decision. Do I get the ebook or the Dead Tree version? What would Carolyn recommend? And would it be readable on a 7-inch tablet? What do you think?
You know what? I get the same royalty no matter what. So
in Germany. But,
I actually haven't seen it I actually have not seen it in the ebook form, but I do know that it's selling well in Europe in ebook form, so I would suggest that.
Probably, yes, I'd say probably, again, the ebook for shipping reasons. Although the book itself is really cute and adorable. And
oh, yeah, what is this, like 6 or 7 inches tall? I mean, it's not very big.
So a 7-inch tablet
my
version.
Laptop.
Yeah, a 7-inch tablet version would be the same size as the book. So
it's going to weigh less on the tablet, though.
It's going to weigh less on the tablet. Rob Kroll asks us, I'm curious how constellations change over time, and maybe there's a simulation somewhere for this. So I think this is about how constellations very slowly morph as stars move away from or towards each other in the galaxy. Do you have any recommendations on how to actually visualize that?
I don't. I mean, I know that, and in fact, from studying astronomy, I know that constellations change because, you're right, stars move through the galaxy. If you were to go right now and leap out from the Earth and go out to the Orion Nebula, for example, the shape of that constellation would change because you're changing your point of view.
Because you're moving, right?
It's you're moving, and it's a three-dimensional universe. There is a program called, hang on a second, Mark, what's the New York version of Digital Sky? Okay, there's a program, I think you can get it on the American Museum of Natural History's website called Party View that might allow you to simulate that.
Okay, and Guido is recommending Stellarium. Stellarium is a free planetarium type software you can use to get around the sky. I've never tried setting it for.
I think I've actually done that, and you can only go so far. It's at the limits of whatever its database is.
Okay, yeah, I think it's limited,
and also,
so you can't really see the constellations move as much.
No, you can, and I'm trying to remember if Worldwide Telescope lets you do that.
Okay. So Stellarium's free, Worldwide Telescope is free, check those out.
And Party View is spelled P-A-R-T-I-V-I-E.
Party View.
Yeah.
I know I've used similar software to show that the sun is in different constellations during different epochs, and so the zodiac thing doesn't work out. But I don't know about how much the constellations move.
Yeah, I think that's a matter of just changing your settings on your planetarium show or your planetarium program. Yeah.
Right. You could probably see something like Barnard Star move. I mean, that's got a pretty high proper motion. I'm sure.
That's right. What is it, 11 light years? Yeah.
Yep. So, try any of those, Rob.
Actually, I think I've seen that in Stellarium, I think.
You have?
One of the programs I play with, I think you can.
Okay, cool. So give those a try. Those are the ones we know of.
Okay.
But yeah, they do move very slowly over time. So as far as you do the Foldham Planetarium show, I've also seen the video work you've done when you were with the MIT Haystack Observatory. So maybe you could tell us a little bit about that, because yay, radio astronomy.
Well, that was fun. So we used to live in Groton, Massachusetts until about 4 years ago. We moved back to Colorado, and I happened to notice this dome sitting over there, and I went over there one day and talked to the librarian and said, do you need any PR work done? Because I was kind of looking for stuff to do. This is after I left Sky and Telescope. And so one thing led to another, and I started doing print work for them, and then somebody came up with this. It might have been the library. Was Madeline there when you were there as an RAU
Sounds
student?
familiar, yeah.
Okay,
yeah.
well, Madeline was a librarian. She came to me and said, we really want to do a series that explained how radio astronomy works, and we also want to do something about space weather, because they do a lot of work on space weather at MIT, Haystack Observatory. So that one actually, they got funded. They got some Roses money, I think, for that, and came to us and said, oh, you want to do 7 or 8 or 9 episodes. It can be about 4 or 5 minutes long about space weather. So that was the genesis of Space Weather Effects. And it basically rotated around Phil Erickson, who was our series host. He took us through all the steps of how it is that you can detect the effects of space weather on Earth's ionosphere and the upper atmosphere and that sort of thing. And then that sort of led into talking about how the sun works and how space weather really gets started. Geomagnetic fields. There was a lot that we had to bring in there.
Yeah. So
and
this is
Go ahead.
Oh, sorry. I was going to say I shared the link out in the event. It's www.haystack.mit.edu/SWFX if you want to check that out.
Right. And there are 9 episodes, and I think they're also available on YouTube. I think they've got them all up there now.
Mm-hmm.
So that was fun. It took us about 3 or 4 years to finish, and we finished the last one after we moved out here. We had to go back, and it also allowed MIT Haystack to buy some equipment like a video camera, a green screen, so we have Phil up against a green screen talking. And one of the interesting things that really has anything to do with science, but I look at the early ones we did and the later ones, and his hairstyles changed. When we first started, he had a lot of hair, and it goes further along, he'd cut it back a little bit.
Oh, Phil.
He's an interesting fellow. He's very good talking to the public. He knows what he's doing. So
what are the challenges of getting scientists to speak for a public audience? Because you had a lot of different scientists from Haystack in those and other videos.
Right. Well, the two. So Phil and Anthea Koster was another one.
Anthea, she's fantastic. Yeah.
And one of them. And Anthea is an expert on what space weather does to GPS signals. And in fact, she went and schooled NASA about this and gave a press conference. And so one of the jobs that I had was to go over there and prepare her for the press conference. She'd never talked to the press before. So she was very, very concerned about how she was going to come across. She's a very soft-spoken lady, so we had to get her to bring her voice up and that sort of thing. Most of them know. Most of them do the open houses, and they know how to talk. They also know that they're very much involved in a science that's very difficult to explain to people, like ultraviolet spectroscopy, which I worked in. You have to figure out a way to make that relevant to people's lives. The one way that they don't want to make it relevant is to equate radio astronomy with listening to the radio, because that's not what astronomers do. They don't listen to the universe. So if you ever say that, and I did accidentally say that once, and I had radio astronomers coming out of the woodwork saying, that's not what we do. So, but they have cool toys. They have these cool domes that you can go and show people. You go to the VLA. I mean, that's a really cool installation. And Carl Sagan, of course, helped make that very popular with the Contact book and movie. So there is this sense that those guys are doing some pretty far-out science. And so in and of itself, going to radio astronomy, you've already got cool toys to talk about. When you get into the technical issues, I think they just don't get as technical as they would, say, with a group of us.
And you did,
although I remember.
Go ahead.
I remember in your thesis you were talking about laying the cable out across the dirt or the grass, and somebody mowed across it. You remember that when you were talking about that?
They made me take that out, or parts of it out.
Because that's a great thing for you to talk about.
I know,
you talk about the trials and tribulations of radio astronomy.
Yeah, they mowed. Yeah. Oh no, I think I had something. Oh, I think whatever I said it way too colloquially. They're like,
probably,
we love it.
Yeah.
We love it when you use it in your blogging. We've read your blog. We love it. It just can't be in a dissertation because I had a few snarky things.
You should have like dissertation outtakes.
I should. They actually really wanted me to write a series of turn my introduction to a series of blog posts, and I haven't done it yet. It's just waiting to be.
Oh, that's too bad. I mean, because it was great. And I had this great mental image of you standing there swearing at that guy with the lawnmower.
They mowed right through our cables.
But for example, the people at Haystack had to go out and talk to all of their neighbors about silencing radio frequency interference when they were doing the deuterium. They had an array there called the deuterium array, and they're trying to detect deuterium in the in the galaxy. And unfortunately, the signal is extremely, extremely weak, and so they had to go and get people to replace stereo components and phones and all this kind of thing. They went all around the area, I think like for 3 or 4 miles around, offering to replace electronics that were causing interference. And so in that sense, they had to go out and really talk to people about what they were doing.
And there, in that case, they don't have, like the radio quiet zone around West Virginia, there's actually laws in place for that kind of stuff.
Yeah.
Haystack doesn't have any legal backing. They actually just had to go and be really polite and ask.
No, the neighbors around there, when we moved to Groton, people were saying, you know that place over there, they used to send lasers out in the sky. Well, it turned out they tested Star Wars stuff out there. Oh, you know, some of the first laser guide stars, I think, were tested out there. Not at the Haystack itself, but in that optical observatory down the road there.
Gotcha. So yeah, people were always a little worried about. People were a little suspicious. Some people were suspicious about there being military applications. Like, no, really, you should just come up. We're just radio astronomers.
Yeah. Although that's another way to engage people, to say, no, that's not really what we're doing here. So.
Yeah.
But those guys were good. Those guys were good at talking about what they needed to talk about. So it worked out pretty well. Colin, when we had him talk about the MWA, it helped that he was sitting there trying to put together one of the little radio antennas in front of the camera.
Yeah. So you did a bunch of stuff about so this is also one of the reasons, not only your writing background, but because you did the stuff with the MWA is why you were so helpful to me in my dissertation. You've helped explain this low-frequency astronomy project that they're building out in Western Australia. Can you tell us a little bit about working on that video project as well?
Yeah, they came to us and said we need to make a nice PR piece about this. So it turned out to be a 10-minute long video about the MWA, which stood for Mil-Euro Wide Field Array, and then became Murchison first. Yeah, right. It was Murchison.
I don't remember.
Well, one was the.
It went back and forth.
There were some political issues, yeah, and so they had. And I'm thinking, well, how are we going to do this? I have no footage, and you can't go out and shoot there. It's 400 degrees out there. Well, somebody had gone out there and done a lot of shooting in the area, because it's also where the SCA test bed is. Right. It's right over sort of the next range was the SCA test bed. And this was, in fact, a pathfinder for some of the SCA technology, square kilometer array technology. So they went out there, somebody went out there, a film crew, and they shot all of this great footage, and I was able to get hold of that, including the one, if you go watch the movie, there's a lizard, one of these giant lizards that lives out there that apparently the director told me they actually will crawl up your back because you're the tallest thing in the entire desert. But it's out there in the Australian outback. It's about 400 miles outside of Perth. So we took their footage, and then we went and shot footage of Colin talking about the project in the library at Haystack, and they were making the connection. This is when I think MIT was more of a lead in the program than they are now.
Yeah, that's been under lots of, again, politics stuff, things, but they are one of the SKA, the Square You are one of the few people that calls the SKA SCA, by the way, and that makes me happy.
Sorry, but yeah, but they do. I mean, they do among themselves. It's just SCA. And I think
of the music. I think of the ska music. Yeah. I always want to Anyway,
well, you know, as a matter of fact, when we were doing that, I was looking around for some of that kind of music, but there wasn't anything I could use. That
probably not as much Creative Commons
stuff. Yeah. So I did the writing. And then Mark and I co-produced it. Mark did the soundtrack. I think I narrated that one. I narrated some of the space weather effects ones as well.
So then that plus your background in, like you said, UV spectroscopy. How is that different from explaining maybe just optical astronomy or things in the sky to people?
Well, things in the sky they can look at. The ultraviolet or radio or whatever, you do still have to depend on visualizations, and they're getting better at visualizations. I think I saw a big turnaround in that when the Chandra X-ray satellite went up, because they really put a lot of time and effort into doing good visualizations. The radio ones are a little bit more difficult, as you know, because you're really just kind of looking at variations in intensity, and it's hard to say, it's hard to see a planet. So look at the radio image of Jupiter that the VLA has. It looks like a little frog, you know, and that kind of grabs people's attention, but doesn't tell you much about Jupiter without a lot of explanation. So any of those non-visible wavelengths, you really have to do a lot more explanation of. You have to find better ways to explain it, and that's what is always a constant challenge for me to do that. And I'm always looking for good visualizations. In the planetarium world, in the planetarium shows, I mean, I am absolutely, we've done this, but every time I say we're going to do it, there's a great scream that goes up in the background saying, we can't show graphs. we can't show spectra because it's going to put people to sleep. And unfortunately, spectra are what tells the story. So in some sense, in one show, we did try to show what a spectrum might look like, or at least what it looks like when a star moves in front of a planet. So you see a little light curve there. So at least that's one way to do it.
That's something.
It's difficult.
Yeah. They were talking about Kepler at ASP, I think, and I think I included this in my DragonCon talk. Kepler doesn't have gorgeous images to show. It's staring at a whole bunch of stars and getting light curves, right? And so part of what they've done is they've employed these artists to do artist conceptions of what the exoplanets might look like.
No, I know one of them, actually. She's a friend of ours, and she
really?
does good work. Yeah.
Very cool.
So Lynette, But yeah, it's like speckle interferometry. How are you going to explain that one? It's just nobody's asked me that one yet.
Now I alluded
to it in the book. Yeah.
Okay.
But if you have a good visualization, and so we had an NSF project that we were going to do about radio astronomy. It continued not getting funded. It's very competitive. It's very competitive now, and we got very close the last time, but we didn't quite make it. And we were going to talk about basically how radio astronomy tells you about black holes. Well, it happened that someone had done some pretty groundbreaking work, and they themselves, a scientist, had come up with a really cool little animation, and we were going to use that. So they're getting more savvy about coming up with animations as well. Yeah. And I think what you're seeing now is a lot of grad students, probably of your age, a little bit younger, a little bit older, that are coming in and saying, they know the visualization tools and they know how to make things work, and they like to play with it. Yeah. So I think going on out, we might see a little bit better visualizations for things like speckle interferometry.
That's a really interesting topic, and now I want to take that on as a challenge. Although my personal thing has always been to figure out a way to explain radio interferometry in that middle ground between we have put telescopes together and Fourier transform. Like there's got to be something in the middle. There's got to be some way to explain that really well. So
and of course the minute you say Fourier transform, you might as well say UV spectroscopy, and they're just
That's why I don't even want to bring that up.
Yeah, they glaze right over. Well, it's funny. I used to sit and watch. I used to at the university. We'd all go to each other's defenses, and I did go to one defense where someone did a gorgeous defense of her work, and then she did a great job of it and everything. And at the very end, her advisor stood up and said, "Would you mind defining the gas laws for me, please?" I was wait a minute, So, but I don't know why he did it. We never did figure out why he did it. And her answer was, "Would you explain why you want to know that?" And he just never asked again. So,
wow. I don't think I told you how mine went. I think the first thing they said is, "So, since you do have outreach as such a big part of your career path, why could you explain the creation and beginning of the universe up to and including the epic of reionization for the public audience?"
Oh my God! And how much time do they want to give you to do that?
They said take as long as you want. That was my first question.
Now you can get away with that. I think even when I was going through, or if I had gone through and done a PhD, they probably would have looked down on that. There was that period of time when people just did not do outreach, or if you did it, you were not considered to be a good, serious researcher. Now, of course, that's turned around, but for a long time it wasn't. Yeah. And so when I was at the university, and I wasn't. And then when I was at the university, I was still taking the classes. I, sat in on all the radiative transfer and all this. But I was the one that they would come to say, "I need to give a talk at the school. Can you help me rehearse it?" Yeah. So I was hey, there might be something here.
Yeah, some people need to bridge that gap, and that's definitely what you're doing.
Jeffrey Linsky was the first one I had to do that for.
Wow. So we got a question on YouTube. It's not directly related to anything we've talked about, but I do want to get answers. This is astronomy. It's Jeff Air 101 is asking, since there is no atmosphere in space, why is there no satellite orbiting the sun in the way that there are Juno for Jupiter, I think Galileo was the previous one, and Cassini around Saturn? And I think the answer to that is there are a couple of things that orbit the sun. The Ulysses, I don't know if the SOHO spacecraft is still in operation, but that was orbiting the sun.
It is, but Ulysses is not.
Yeah. Ulysses is not, but that was orbiting the sun for a while. And now there's the Solar Dynamics Observatory, which is technically orbiting Earth, but always pointed at the sun. So there are definitely several missions that are looking at the sun, specifically at the sun as well, tying back to what you were saying before, because it's so important for determining space weather and seeing the effects that's going to have on Earth.
Well, and we really don't know. I hate to say this, but we really don't know a lot about the sun yet.
Yeah.
I mean, we have a lot of knowledge. We really do, but there's just still some of these burning questions like the magnetic fields, like flare, you know, what is going on with these magnetic fields and why are we seeing what we're seeing? It was only just recently that that anybody even came up with a reasonable idea of what causes the superheating in the corona.
Yeah, yeah.
And so, and that's after years and years and years of taking data. So while we know a lot, there's just a whole lot more that we don't know. I mean, we know about the process of fusion. We know about, you know, the sorts of things that cause the sun to actually do what it's doing in its core. But boy, once you leave the core, what else is going on? You know, it's just very hard for us to probe that. Helioseismology is helping us a lot with that.
Yeah, right, looking at the perturbations of the sun.
Right, right.
Yeah, that's another, there's a powerful tool in the Solar Dynamics Observatory that does helioseismology. And I think they have something to determine what's going on with the magnetic fields as well. I don't remember the official word for magneto something oscopy.
Well, it's just turning out to be a much more complex magnetic field than we thought. Same thing with Mars, actually. Mars has, you know, everybody always says, well, it doesn't have much of a magnetic field. Turns out it has these little localized ones that are incredibly complex.
Yeah, yeah. Oh, all right, well, we are getting close to the end of the hour. I'm going to do a wrap-up of the upcoming shows, and Carolyn, after that, I will give you the last word on maybe you could tell us something about what you're thinking of working on next, or what's been your favorite thing recently. But first, I want to let you guys know that tomorrow we have a special hangout in our series. Yes, we're calling it the series about the dwarf planet / largest asteroid series. We will be joined by several scientists who are affiliated with the Dawn mission to Vesta and Ceres, and specifically we will actually talk about the results of spectroscopy, but we promise we will have actual pictures and not just squiggly lines. If you missed our last hangout, go to youtube.com/astrospherevids, and you can see the previous hangout about Ceres. We talked about how the kind of things we know about it now, what we expect, whether we expect to find a watery world. So we'll continue that conversation tomorrow. I'm going to double check the time. I think it's at 10 a.m. Pacific, because that's at like noon Central my time, 1 p.m. Eastern. I've probably got a link in there that'll show you the time zones, and Google Plus will show you the time zones as well. So check it out on the CosmoQuest page. The event for that. So that is tomorrow's next installment of the series. It's called Ceres: Great Expectations, as the Dawn spacecraft makes its way there. Friday at noon Pacific, we will be doing the weekly space hangout. We again apologize profusely for missing last week. Not only did we miss it, we didn't cancel it, and then we didn't have a backup. And you guys, so a bunch of you guys showed up and were in the comments wondering where the heck we were, and then you ended up having a fabulous discussion about astronomy and sharing your astrophotos amongst yourselves and talking about the news. And so that makes me really happy to see that, and again, we apologize, and we're totally going to make it up to you this week by being awesomer than ever. So thank you again, guys. Ted's Weekly Space Hangout on Friday. Virtual Star Party, I think, was canceled last Sunday because of weather problems. They actually did let people know it was canceled. They're going to try again this Sunday night, I think around 8:30 Pacific, to do the Virtual Star Party. And then I think Astronomy Cast is once again on hold while Pamela and Fraser are traveling, but I'll find out as that gets closer. So that's the upcoming hangout schedule from CosmoQuest and all of our affiliates. And I want to give, like I said, Carolyn Collins Petersen here, the last word. Tell us where we can find you, maybe what you're working on next, and what's been your favorite thing to work on so far.
Oh, I think I'll start with the last one first. My favorite thing so far is basically working on the next Full Dome show that I've been working on. There are actually two. One of them is a continuation of a first show that we wrote some years ago called Larry Cat in Space, and it's about a little cat who goes to the moon. And he went to the moon in 1990. And then the other one is about Hubble Space Telescope science. So I've been in the pre-planning for both of those, and those just kind of keep me occupied. I'm also working on Star Map. We have a lot more work to do with that. This is actually my first Google Hangout where I've been a guest, so I've actually survived it. It's been a lot of fun.
Yay! You were one of my easiest trainees with the technology. You were like, oh, just click this, click that. I got it. So.
Well, you can find me online at my thespacewriter.com. I blog every day on there, and there's an email link to me, and I'm also at SpaceWriter on Twitter. On
the Twitters. Yep, and you're on Google Plus as well, so check her out there.
Yeah, I'm still learning about Google Plus. I'm still not quite sure about it yet.
It's fun. There's lots of scientists on it. It's good time.
Yeah.
And Star Map Media, check that out if you're on an iDevice, and maybe ask the developer, send him, hey, have you thought about Android? Maybe if he gets some requests, he might be more.
Yeah, we never get that question.
Because you never get it. Yeah, be like, hey, we love it. Do you mind? Be nice.
Well, what I'd really like is if anybody uses it to send me feedback on what they think about the stories, or future stories they'd like to see. It's really just out now, so we're really starting to get feedback about the stories now.
Excellent, excellent. All right. Well, thank you so much, everybody. Thank you, Carolyn. Thank you, co-host Georgia.
Carolyn, yeah, very great.
Thank you.
All right, so we will see you guys next week on Learning Space. Bye.
Yay. Goodbye.
So what he wanted was to have that sort of friendly, arm on the shoulder, see this thing up there kind of approach in this show. And when he came to me, I immediately said, well, this is like all the planetarium shows that I used to give, doing Star Talks. And then in addition to that, we're mixing in little bits of audio-visual entertainment with it. There's a narrator, there's music that comes with it, and we put in one story, we'll talk about not just the star, but also some history of it, like what the history of the constellation is, what Greek gods and goddesses people saw here, that sort of thing. So it's a little bit of a complete, what I call a Star Talk, what we in the planetarium community call the Green Arrow Show.
Yes.
So we still do call it the Green Arrow Show.
Nice.
So, well, I don't know, you have a planetarium, do you have a green arrow?
We just got a planetarium, which has a red arrow.
Okay, well, the Great Arrow Show then. Yeah.
I do public observing nights and in Edwardsville, Illinois now, and we have the green laser pointer. So
yeah, well, it's the same thing.
That aspect of both.
Yeah. So that's how StarMap Media came about. So think of it as the next generation of StarMap. Well, the media program itself is actually a standalone module that you can download for free, and you get 2 stories with it. There's a Sky Tonight, and then there's a tutorial. He also embedded that into the standard StarMap show, StarMap programs as well. So no matter which StarMap you get, if you get StarMap Media or StarMap Pro or StarMap HD, you also get StarMap Media embedded in there.
Cool, cool. So Guido Bibra asks a question that's been on my mind as an Android user. Are there any plans to port the apps to Android as well?
Yeah, I ask him that question a lot.
If you're watching on the YouTube page, we are tracking those comments. Sometimes they come in a little bit slowly, but we will get to them. Unfortunately, we don't have Twitter tracking anymore. So if you can use the YouTube or the Google+, we will see those comments. So send us any questions for Carolyn or for me and Georgia along the way. Send us your comments, and yeah, hi everybody. Why don't we go ahead and get started and talk about your new app that you've started working on and sent me some codes for. It sounds like a Sky app that's got a whole lot more, some storytelling aspects to it.
Well, it's called StarMap Media. And it's actually the latest generation of a series of apps called StarMap, which was created by a gentleman named Frédéric Descamps in France. So the first StarMap was actually created 5 years ago.
Okay.
He contacted me a little over a year ago, actually, asking me if I would be interested in writing what essentially were little planetarium shows to play inside the app. And so we started working on that, and I've created 32 of them. 29 of them, or 30 of them, are live now. And they're basically between 15 to 17 minutes long, and they not only do they tell you about what you're looking at in the sky, but they guide you and help you find things in the sky. So if you're holding it up and you're listening to the story about the North Star, it actually puts a little pointer up there to show you how to find the North Star. When you get there, then it goes into a little talk about what the North Star is and why it, and there are a lot of security issues with Android, and so he's thought about it. What he may actually end up doing is going to a web-based application, which is then pretty much independent of a platform.
Right.
So you could be on whatever platform. That's going to take a little bit more development. We just actually had a telecon about that this morning.
Okay. Okay. Cool. Cool. So there are different levels of the app. There's the free app. There's an HD app. There's the regular light. What are the different levels?
Okay. Yeah. So
subscription.
So let's go back to the beginning for a minute. He basically released StarMap, and that became StarMap Pro, which is what now shows on the iPhone. StarMap HD, I think, and I'm kind of guessing on this, but he mentioned once that it came about because people wanted to be able to play StarMap on their iPhones. and I mean on their iPads. And you can put it on the iPad, the iPhone app, but it isn't as good. So
it's
he
like
basically
this big, on the screen.
Yeah. I mean, well, you can do the 2x on it, but it still looks like crap. So no, he came up with the HD for the iPad.
Okay.
And then Star Map Media is the new one that he came up with. Light is a free version, and it's apparent. I think very soon now it's going to be that you can get Light, and if you want to upgrade it to the full app, then you just do an in-app purchase.
Okay. Very cool.
And I'm still a little bit new to in-app purchasing. I see it in games and things like that. It's complex. It's more complex. I don't program in Mac, or in Apple, so I'm not really sure what they do. I did go through a little bit of an exercise to see what it takes to make an app using the Apple platform.
Hey. Hi everyone, welcome to this week's Learning Space. This is the Nicole is still recovering from Dragon Con edition. I am your co-host Nicole Gugliucci and postdoc with CosmoQuest, and I have with me Georgia Bracey, our formal education lead with CosmoQuest, and we bring you a weekly show about space and astronomy education and outreach topics every Wednesday. Like I said, I'm still recovering from the amazing time that was Dragon Con, and I know you all had Georgia and Ellen Riley last week talking about Investigate, and I did not get to see that episode yet, and I'm super excited to check it out, since that's all about our newest curriculum, all about asteroids. So thank you, Georgia, for covering for me while I was in Atlanta.
Sure.
We have with us today Carolyn Collins Petersen. So hello.
Hi.
And we have who's the space writer on Twitter, and we have a whole bunch of stuff to talk about, including a new app she's been working on, a book that came out recently, and we'll be talking about some other cool stuff along the way. And I want to let everyone know to thank you, first of all, if you're sharing this link and sharing it with your friends and spreading the Learning Space love. If you want to send us a comment, we are using Comment Tracker in Hangout Toolbox to check the event page. So if you're watching this on Google+, on the event page, anywhere it is shared from the event page should be picked up as well. Anybody who's been sharing it out over the last few days, that should come up as well.
It hasn't always been our North Star, and what Polaris is, what kind of star it is, that sort of thing. So it's a little bit of an interactive planetarium show is the way I think of it.
Except the planetarium is the real night sky. That's so cool.
That's pretty much it. Yeah. So with the map, it's kind of hard to see on this. This is, I don't know, it's kind of hard to see, but this is how it looks on the iPhone. It actually plays on the iPhone and on iPad, and you select a story. Star Map itself is also a planetarium, mobile planetarium program. That's how it got started. So you can hold it up to the sky, and it will show you what's up in the sky at the time. And so at the time that you're looking at it. So if right now, if I had the sky turned on, it would show me while the sun's up or something like that. But in 5 hours, it would show me whatever stars are overhead at my location. So it takes the GPS reading from your phone or your device. It uses the compass that's in there, and then it also knows where you are because you told it what city you live near when you first go into the app. So that's Star Map itself. And that is not dissimilar from a lot of other mobile planetarium programs that are out there, like Sky Safari and that sort of thing, but Star Map was actually the first one to come out in the App Store and was very popular. So Frederick, for many years, since he released it about 4 or 5 years ago, got to thinking, what more can I do with this? So he was always adding more databases, more objects as things would come up, and then he got to thinking about, well, it still doesn't help you through the sky when you're actually out there with somebody. Say you're out there with some amateur astronomer who knows the sky, that person's going to tell you, okay, you see that star over there, that's the star. This is this constellation. Here's how you get to it. Here's how you start.